All right, so today what we're going to do is we're going to continue our look at exponents. And we're going to talk about what are called the expansion rules. And this is what happens when you have a bracket raised to a power, or an exponent, or an index, whichever word you like. And we've talked about this a little bit. We're going to just bring it to the next level, and then we're going to continue that for a bit. Okay? So the first thing I want to talk to you a bit about is the idea of some algebraic notation. So we already said that the difference between algebra and arithmetic is the introduction of the variables, right? And so all algebraic notation, expressions or equations, are made up of terms. Remember that? And all terms have exactly how many parts? 4 parts. Excellent. Okay? And the first part of every term is its sign. So we can always tell when one term stops and the next one begins every time we see a sign. And it's really important that you understand when that happens, because what happens in a problem is going to depend on how many terms it has. So what we're going to look at is we're going to look at how many terms in and you're going to learn a new math word today, maybe, may not be new to all of you, a polynomial. Woo, hate it already. Good. Polynomial. Poly is the Greek prefix for many. Nomial just means names or numbers in this case. So, literally, polynomial just means many terms. Okay? So a polynomial is simply a collection of terms. Now, this may seem a little premature because you're not going to be asked any questions about polynomials, but if you think about expanding brackets, your life will be much easier if you understand that if you change the number of terms, then you change the thing that's going to happen. Okay? So I think that introducing this here makes a lot of sense. And besides that, the more exposure you have to something, then the better you're prepared you're going to be for it later. Right? So, if you have a collection of just one term, the name for something with one term is called a monomial. Mono means one. Right? So I'm just going to do little examples here. An example for a monomial, and you could write it down there, but I'm going to run out of room pretty quickly, so I'm going to write it up a little bit. For a monomial, say you have negative 4xy to the third. Notice there's only one sign there, isn't there? So that means it's all one term. So this is all one term. All of those pieces of it are all connected with multiplication, not with addition or subtraction. Do you agree? Because they're all just stacked together, right? Another polynomial that you're going to see a lot of with 2 terms is called a binomial. Like bicycle has 2 wheels, right? So in that example of a binomial, oops, can't spell, might be negative 4xy to the third plus 3xy. Now, we can't put those together because they're not like terms. Right, because they both have an xy in them, but one of them has a y to the third. Remember, to be like terms, they have to look identical. Just the only thing that can be different is the number in front. Okay? And finally, the only other one that has a special name is when you have 3 terms, and that's called a trinomial. And that just means, tri means 3, right? Like tricycle. So we have negative 4xy to the third plus 3xy minus a 7. Now, that could be any terms. I'm just making these up, right? But do you see that here's the first term? That plus means that's the second term. That minus means that's a third term, right? So every time you see the sign, it's like this, it's the beginning of a new term. So it's like seeing the car bumper. That's the first part of the car, right? So you know it's one car stops and the next one begins. So always think about that sign as the splitting point, the breaking point. Okay? Now, I'm going to use this terminology when we're talking about expansion because it makes sense. Okay, so that means you have new words to me. But just think of those prefixes. Mono means what? 1. Bi means 2. Tri means 3. Right? So if I say monomial, you should think what? One term. Now, can it have X's and Y's and A's and B's and C's in it? Absolutely. It can be horrible. Gigantic. Who cares? Not going to be. But it's all one term. Okay? And you'll see why I'm introducing these in just a moment when we talk about these. So polynomial is just the overarching definition of any of them. But if you want to talk about specifics, it's monomial, binomial, trinomial. Any more than that, it would just simply be a polynomial with 4 terms or a polynomial with 5 terms. They don't have special names. The reason these have special names is these are the ones you're going to see the most. Okay? So, what we want to do is, we're going to continue our talk about expanding brackets. And the way we expand the brackets, or what we expect to happen, is going to change depending on the number of terms inside. Okay? Right? Everybody got that one? Ready? Okay, so let's take a look at what I mean. Yesterday, we talked about expanding brackets when you had like a b to the third raised to the second power. If you look at that, this is a monomial, isn't it? Because there's just b to the third in there. There's no addition or subtraction, is there? So we know it's a monomial. So with the monomial, you can use that shortcut. But I'm going to warn you that that shortcut creates more problems than it solves. So instead, what we want to do is, instead of saying, so we could say b to the, the shortcut is, if you have an exponent raised to another exponent, a bracket raised to an exponent, what can we do as the shortcut for those? Times. Yeah, so it's just b to the 6. But again, I'm going to warn you that it's a bad idea in most cases. Instead, if the exponent is a small one, like a second power, you should really think of that as b to the third times b to the third. Which means you have multiplication with the same base, so we keep the base, and what do we do to the exponents? Add them. Now, not only does that keep you focused, but it also means you have one rule instead of that weird special case rule, so remember. Because this is the only time you would ever multiply exponents. And it doesn't work unless it's a monomial. So say, for example, I had b plus 2 raised to the second power. Is that a monomial? No, because I have that plus in the middle. The b is one term, the positive 2 is the second term, so that is a binomial, right? And if you just tried raising those things to the second power, you would be completely and absolutely wrong. So if you try to use the shortcut and it's not a monomial, it just doesn't work, okay? And you're going to see how to do these later. Some of you might already know, but we're going to talk about how to do those later. So if I had a squared plus b to the third raised to the second power, could I just multiply those exponents by 2? No way. Because I have that plus, that means that's a binomial, and you cannot use that shortcut with a binomial. So the reason I'm showing you this is I'm trying to convince you not to use the shortcut. Because more times than not, you're going to have more than one term. You're going to have a binomial or a trinomial in your bracket instead of a monomial. It's actually very rare to have a monomial in your bracket. But right now, that's all you're going to see, right? So I'm trying to kind of project a little bit because most of you are still thinking, I'm multiplying those exponents because it's a lot easier, right? Please don't. Okay, so what we're going to do is we're going to go to the lesson, and we're going to just, today all we're going to do is something that we've already talked about. Yesterday I put some of these on the board, but they didn't have any in the homework, and today they're going to have them in the homework. So remember, I put things on the board like this raised to the third power, right? In our homework last time, we just had things like this raised to the third power, right? Very simple. But this time we have a coefficient, we have two variable terms, and one of those variables has an exponent. So what we're going to, and it's raised to the third power, so that simply means to expand it. Now, could I use the shortcut on this one? Yes, you could. Because it's a monomial, you could definitely use the shortcut, and I'll show you that as well. But I would not if I were you. So we're going to take 7 times 7, which is, and I hope you have your calculators out, times another 7. What's 49 times 7? 343. Thank you. And then we'll take a times a, which is a to the what? Third. Excellent, because there are 3 of them. Remember that if you don't have an exponent, the exponent is a 1. And when you have powers with like bases, you simply add those exponents together. Then we're going to take b to the second times b to the second times b to the second. So again, same base. So I'll keep the base. And what do I do to the exponents? Add them. 2 plus 2 is 4 plus another 2 is 6. And there's your answer. Quick and easy. So it may look like more work to expand these out, but would you rather take a shortcut and take the chance of getting 3/4 of the problems wrong, or simply write it out and get all of them right? Your decision, not mine. Okay? Now, if we were doing the shortcut, we would have to remember that every time we don't see an exponent, that means there's an exponent of 1. So 7 to the 1 times 3 would be 7 to the third. A to the 1 times 3 is a to the third. B to the 2 times 3 is b to the 6. And 7 to the third, they might leave it like that, or they might multiply it out. So you'll see that using the shortcut gets you the same answer when they're monomials, if you're careful and you do it all right. Okay? So, but I really hate the shortcut. Can you tell? All right. So what we're going to do is we're going to look at more problems like this today so you can practice being able to expand those brackets. We're also going to look at what happens when you have a fraction raised to a power in the bracket. It doesn't change anything. It just means you take the whole bracket times it, what? Times itself. How many times in this case? 3 times. And then you multiply with fractions, you simplify, but it's not going to simplify because it's the same number over and over. So in the top I have 1 times 1 times 1, which is 1. In the bottom I have 2 times 2 times 2, which is, and there's your answer. So if you just expand it and make it all multiplication, generally for most people it makes it easier. Okay? Now as you move forward and you get more sophisticated with your algebra, then shortcuts make sense. But when you're just still working with learning the basics of it, it just doesn't make sense to take too many shortcuts. Okay? So let's just go to our, especially when you start working with signs, go to our book and look at some of the problems they're going to have. Now they call these expansion laws. Really doesn't matter. Okay? And they go through some of those exercises. We're just going to go through the work and see what's going on here. So remove the brackets and simplify. Now, if you look at all of these, is there any addition or subtraction inside any of these brackets? No. Oh, be careful. No addition or subtraction, right? Okay? There's more than one letter, but they're all connected with multiplication. So that makes them all monomials. So could I use the shortcut on this one? Absolutely. And I might want to say on this one raised to the 6th power, right? Just because 6th power is a lot of stuff. It's very rare that you'd ever raise something to the 6th power, by the way. So instead of writing AB times itself 6 times, and then counting up how many A's and B's, right? 1, 2, 3, 4, 5, 6. Because it's all one term inside, these are monomials, then I can simply raise everything in there to the 6th power. Or in other words, multiply the exponent on the inside times the exponent on the outside. But remember, I have two bases in there, right? So that means they both have to be raised to that power. Not just one of them, but both of them. So a to the 1 times 6 is going to give me a to the 6. B to the 1 times 6 is going to give me b to the 6. If you expand it, you'll get the same answer. 1, 2, 3, 4, 5, 6 factors of a is a to the 6. 1, 2, 3, 4, 5, 6 factors of b is b to the 6. Okay? So both ways. If the exponent is very large, that's about the only time the shortcut makes sense. Otherwise, expanding it makes a lot more sense. Okay? Let's look at this at h. We have an exponent of 2 on there. So would you expand it or use the shortcut? I would expand that one because it's only an exponent of 2. That means just that one thing times itself, right? So it just makes more sense to be careful and expand it. So you get 5gh times another 5gh. So we just multiply. 5 times 5 is? G times g is? G2 or g squared. Yep, good. H times h is? And there you go. You're done. Okay? But you've made sure that you've multiplied every single piece of it because we expanded it. Okay? And it's especially going to be true if we have some signs. Okay. Let's look at a couple where we have some fractions. Ready? Okay. All right. So don't worry about the fractions. It just means to take the entire bracket times itself that many times, or raise everything in the bracket to that power if it's a monomial. So look at something like, look at g. Whoops. Keep forgetting to hit my button. Look at g. We have a q over a 2 raised to the 4th power. Now we could expand that out, but 4th power, that's quite a lot of them, right? But we could. Q over 2 times q over 2 times q over 2 times another q over 2. And then just multiply fractions of the multiplying fractions. We multiply how? Straight across. So q times q times q times q is q to the 4th. 2 times 2 times 2 times 2 is 16. Good job. And there's your answer. Now, or you can remember that everything inside has an exponent of 1. So q to the 1 times 4 is q to the 4th. 2 to the 1 times 4 is 2 to the 4th. Q to the 4th can't change, but 2 to the 4th is 16. So you can still use the shortcut because these are monomials. But be careful if you do. Okay? Because what people forget is it's not just the q raised to the 4th power, it's everything in there raised to the 4th power. Okay? But if you expand it, it makes it very obvious that you're just multiplying numerators and denominators. Okay? All right. And here we've got some mixed ones. No signs. How rude. Oh, well. So good. So look at something like g on this one. We have 3g raised to the 2nd power times 2g. Just take this to notebook paper so it's easier to see. Now, I'm told to multiply those two things together, but the order of operations says before I do that multiplication, what do I need to take care of? The bracket. So we'll take care of this bracket first. So that's 3g times another 3g. 3 times 3 is 9. G times g is g squared times 2g. And now I'll just multiply those things together. They're not like terms, so can I multiply them together? Multiply is fine for anything, right? But I couldn't combine them. So 9 times 2 is And g to the second times plain old g is g to the third. Exactly, because there is no exponent. You assume it to be a 1. And when you're multiplying powers, you just keep the base and add the exponents. Okay? So don't get confused when there's more than one operation. Okay? All right, let's see what else they do to you. I think it's pretty much the same stuff. Don't worry about number 6. So here, just expand it and multiply all the pieces. So say we have w to the second over 3v raised to the second power. So that literally just means take that thing times what? It times itself, right? So in the top, w to the second times w to the second is w to the fourth, because you keep the base and add the exponents. In the bottom, 3 times 3 is, and v times v is v to the second or v squared. And you're done. So it's a lot easier to think of using one rule of add the exponents, expand it, and add the exponents than it is to remember the shortcut. And more importantly, when not to use the shortcut. Okay? So that's what we're going to work on. For the rest of the time, you're just going to do that exercise, and all you need to do is do 1 through 5, omit number 6. Don't worry about it. Now, the reason we're spending so much time on this is that this is a critical skill. You need to understand how raising terms to powers and expanding brackets works. We're going to spend a lot of time on this. A couple more classes, but we're going to expand on them and do binomials and trinomials later. Okay?